watch this later. So we're just coming back from lunch and we're continuing on with 4.2 and we're on letter D. This one's talking about a flagpole. It says find the height of a flagpole that makes a shadow 13 feet long where the angle of elevation of the sun is 59 degrees. So let's draw our picture. I've got a flagpole. It's 90 degrees in the ground. And then I've got the ground. Oh, that 90 degrees is rough. We don't know how tall the flagpole is, so I'm going to write H for height. And it tells me that the shadow is 13. What is the shadow? Is that the horizontal distance or is it the diagonal distance? Horizontal, very good. Shadow is the horizontal distance. So 13 feet is that horizontal distance. And then my angle of elevation is 59. So I'm going to put that down here in the corner. I didn't label any points because I didn't need to know where anything was. I know a flagpole is vertical. I know a shadow is horizontal. I knew enough to draw my picture. Now we have to label it so we can figure out which trig function we are using. So what's my opposite? What's my adjacent? What's my hypotenuse? The other one. And which trig function am I going to use? Tan. Very good. Well, tan. O and A. So I'm going to write tan of 59 equals H over 13. Now that was pretty easy. I just plugged it in and I just have one step in order to simplify. Let's move our 13 to both sides. Oops, that's not what I wanted to do. Multiply by 13 on both sides. So now I have 13 tan of 59. Perfect. I'm just going to plug that straight in. 13, oh, that's not what I wanted. 13 tangent 59. Enter. You should get 21.6. I am still in degrees. If you did not get 21.6, make sure that you're in degrees. In this case, you have to be in degrees. You don't get to be in one or the other. You have to be one. Becca? Nope. How you know is based on the picture and what's given to us. Do you see how this tells me it's 59 degrees? So since I'm putting in degrees, I have to make sure my calculator is in degrees. It's essentially like you need to make sure that we're speaking the same language. So like if I'm talking about degrees, I need to make sure my calculator is still in that like degrees language mode and not in radians. Okay, so it doesn't say it's radians. It'll either specifically say radians or you will know it's radians because it's in pies. Jared, question? I didn't know which trig thing is. Great question. Remember when we wrote at the top SOHCAHTOA? Based on what I have, I use that trig function. So I have opposite and adjacent. What, on the last one? I have the angle and I have the sides for adjacent and I want the opposite side. And so I know that I don't technically have opposite, but I want to know what opposite is. Like that is the variable I'm looking for. So I have opposite, I have adjacent. That means I have to use tangent, TOA, tangent, opposite, adjacent. Let's review the one above that. Why did I use sine on the one above that? Same question, right? I have my angle. I knew opposite. And this one, I wanted to find hypotenuse. I knew that I wanted to find hypotenuse because it said how far is the airplane from the airport, and you guys told me that's the diagonal distance. So in the one above, I want opposite and hypotenuse, which opposite and hypotenuse is sine. You getting there? Okay. We'll get there, I promise. Just hang on. You can think about the sun is in some ways behind the flagpole in order to cast a shadow, right? it has to be, it can't just be like straight above it or else there's no shadow. In some ways, it has to be like over here somewhere. Like, and I know that it may look like it's above. Remember how we talked about how angle of depression and angle of elevation are the same angle? I can call them whichever one I want, and I know that that angle is always down here. You could also think of it from the other side and the shadow being cast down this way. Okay. You're welcome. Let's do another one. This one says, what is the angle of elevation? So this one's a lot like letter B. We have to find the angle. What's the angle of elevation of a man looking at the top of a building that is 48 feet tall and he is standing 100 feet from it? So let's draw that picture. I've got a building that's 48 feet tall. And then I've got a man over here standing 100 feet from it. And it wants to know what his angle of elevation as I look up to it is, which is right this theta. Everyone okay with how I labeled my picture? Let's decide opposite, adjacent, hypotenuse. What do I have? Good. What's my adjacent? What's my hypotenuse? Unknown. I have opposite, I have adjacent. I need to find theta. Which trig function am I using? Tangent. This one's a little bit easier because I gave you both the sides and we were looking for the angle. In the other ones, I would do some kind of variable to represent which other side you're looking for. So I'm going to write tangent of theta equals 48 over 100. Do you remember how we find what theta is? My inverse, good. Tan -1, second tangent. Theta is equal to tan -1 of 48 over 100. And I'm physically going to do second tan 48 divided by 100. Now, I have not moved from degrees. I've been in degrees this whole time, so my answer is in degrees. If you wanted to do it in radians, that's also fine. If you were already in radians, as long as you tell me which degree or which unit you have, that is fine. Second tan 48 divided by 100. And if you did that, you would have gotten 0.4475 radians. All right. Questions, thoughts, comments so far? As long as you label it, I'll figure it out. If I care enough, I'll ask you for in degrees. I would say find the angle of elevation in degrees or in radians. Normally we just are used to seeing it in degrees, so I would try and stay there, but if you're in radians on accident, that's fine. Just recognize that. Okay, any questions, any thoughts? We're going to do a kind of shift our focus kind of to something we did at the beginning of 4.2 now that we're moving into 4.3. So at this point, we are done with 4.2. That 4.2 homework is due on Friday. If you want to bring it to me in person tomorrow, feel free to. If you want to turn it in online anytime between tomorrow and Friday, please do so. But that's that. We are done with the calculator now, so I'm getting rid of it. We're going to do number 1, A and B before we move on. Or before we're done for today. So that's really all I need to accomplish before we leave. This looks different and confusing, but I'm going to promise that it's just like what we've learned earlier in this unit. I'm going to zoom in on my graph. It says evaluate the 6 trig functions. I have given you an angle that's on my coordinate plane. It's a standard position angle, and it's bigger than 90 and it's bigger than 180. Remember how we talked about bow tie angles on Monday? You remember those? Which axis do they always connect to, the X or the Y? X, good. I love how strongly we answer that. They always connect to the X. So I'm going to draw my bow tie angle here that goes with theta. I have to use the side that's already there. We call that the terminal side. So the side that's already there I'm going to use, and then I'm going to drop a perpendicular to the X axis to finish my triangle. And technically the reference angle is that angle that's in the corner of the triangle next to the origin right there. I'm calling it theta because it's the same thing as theta if it were to go all the way around. The reference angle and this angle are the same. They work together. Now, I gave you the x and the y values, and that's important because that tells you your horizontal value and your vertical value. So -3 is my x, so that means I went from 0 to -3 on the x-axis. My horizontal distance is -3. Same thing with -4, that's my y. So my y, I'm going down 4 units. From here, I went down 4 units, so this vertical distance is -4. The reason it's on a graph is because if I told you that a side of a triangle was -3 or -4 before, we'd be like, that doesn't make sense. It makes sense because we're on a coordinate plane and we're allowed to do those distances. How do you find the last side? Pythagorean theorem. So we're going to find hypotenuse by doing Pythagorean theorem. -4 squared plus -3 squared equals c squared. Welcome to your new best friend. We'll be doing a lot of Pythagorean theorem. 16 plus 9 equals c squared. 16 plus 9 is 25. Ooh, this worked out nicely. Your hypotenuse is always, 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 always positive. Always, always, always positive. My x and my y can be negative. My hypotenuse will be positive. Did I answer your question? Perfect. So you don't have to worry about a plus or minus here. The hypotenuse is positive. Now, if I was finding one of the other lengths, we would have to kind of think our way through it and be like, depending on what quadrant we are, should it be positive or negative? But if we're finding hypotenuse, always positive. So I'm gonna label that 5. Also, do you guys remember some of the perfect like triangles? 3, 4, 5. Is that like something that you recognize in your head? Did anybody know it was 5 without solving? That's just a fun trick. The more math we do, there's special ones that always pop up. So multiples of 3, 4, and 5 always make a perfect triangle. All right, now we're going to do our trig functions for all of these. So let's label opposite, adjacent, hypotenuse. What's my opposite of this little triangle? What's the opposite side? -4. What's my adjacent side? What's my hypotenuse? Very good. Now I'm just going to list sine, cosine, tangent of these. What's sine? Over 5. Good, give me all of it. So in this case, L, it's not just X or Y, that's with the unit circle. I love that we made that mistake now and not later. So since we have an actual value for our hypotenuse, we're going to use that value with us. So -4 over 5. What's my cosine? Perfect. What's my tangent? 4 over 3. Why is it not negative, Brooke? They're both negative. They're both negative. Very good. Now we flip everything. Cosecant is going to be -5 over 4. Secant is -5 over 3. And cotangent is 3 over 4. Not too bad, right? We had to draw our bow tie angle, we had to find the third side, and then we had to fill in our trig function. Let's do the other one. Got my reference angle. Theta. What's my horizontal side? What's my vertical side? Good. And then we got to do Pythagorean theorem to find the last one. 3 squared is 9, -2 squared is 4. All right, I get kind of a gross radical, but that's okay. And I would actually rather a radical that I don't have to simplify. And for right now, for these problems, I don't need you to rationalize. So when we're about to fill this in, you do not need to get rid of the radical in the denominator. So what's my opposite side? Good. What's my adjacent? And what's my hypotenuse? Good. So sine is perfect. What's cosine? Good. What's tangent? Perfect. And then switch them all. Root 13 over -2, root 13 over 3, 3 over -2. Okay. We call that rationalizing. And for these, I do not need that. For the unit circle, I do want that. Now, I know that this is annoying. I keep doing this, but I do want to preview the next problem because we got farther in the other class. So just listen to me for 1 second because this is literally what we just did. This one just tells me point P is on the terminal side in standard position. That just means I'm going to draw a picture just like I did before. I'm drawing a nice little coordinate plane, and I'm going to put point P where it belongs. Where should 2, -2 be? Which quadrant? Fourth quadrant. 2, -2. So my terminal side is like the diagonal, the hypotenuse that cuts through my triangle. My vertical and my horizontal are told by my point values, and my theta is in the inside by the origin. What's my horizontal side? 2. What's my vertical side? Good. And then we find our hypotenuse. We will speed round these next time I see you, which is tomorrow, but the other class got further, so we're going to have to go pretty quick to catch up. You can start on 4-3 homework if you want. If not, 4-2 is definitely due on Friday, and I already put a submission box for you. I'm going to stop the recording, and I'm going to come.